In the graph, you can see the displacement time graph of the two balls, ball 1 and ball 2. Ball 1 is dropped from the rest, which means that the ball 1's initial velocity is 0 and it is dropped from the height h from the ground, whereas the ball 2 is thrown vertically upward with some initial velocity u, and at some time t, where even if you see from the graph where these their graphs intersecting, at that time, at this time, what is happening, their vertical position is same as you see from the graph as well, that they are at the same vertical height from the ground, and you have to calculate this time value in this question. So let us see at this time where the two balls are. So at this time, the ball 1 has covered, because that is dropped, the ball 1 has covered, let's say, the displacement x, that is a negative displacement, and the distance is x downward. So it means that this position above the ground is h minus x, which is same for both of them. So we can apply the Suvat equation, because this is a free fall motion, acceleration is constant. So if we apply the equation for the ball 1, so distance covered by the ball 1 is x, as you can see from the graph as well, but the displacement covered will be negative x, initial velocity is 0 into t plus 1 over 2, acceleration is equals to negative g into t square. This is the time at which the both are at the same height. So we will have 1 over 2 gt square. This is the distance traveled. Now we can apply the Suvat for the ball 2, and we want to know that how much the ball 2 has moved during this time. So we will once again apply the same equation, because you know the ball 2 is moving upward, so how much it has moved up, that is h minus x during this time. So that is ut minus 1 over 2 gt square. And now we can plug the value of x over here. So this will become h minus x is equals to ut minus x, and as we have minus x on both sides, so we can cancel out, or you can add x on both sides. So what we got, h is equals to ut, so hence the time t is equals to h over u. This is the time when they are at the same height from the ground. So option C is the right answer.